students, welcome to RECTV. This is Kalyan and I am the faculty of Mathematics and Physics. So students, in this session we are going to do proofs and numericals based on converse of basic proportionality theorem, means converse of Thales theorem.
Please subscribe and don't forget to click the bell icon for the more updates.
Let us see what the problem is in this video. Right, see here. D and E are respectively points on AB and AC such that AB equal to 5.6, AD equal to 1.4, AC equal to 7.2 and AE equal to 1.8. Then show that DE is parallel to BC. Actually, before doing this problem, let us recall the converse of basic proportionality theorem. What it is, let us see. Just see. Here, if one triangle is given, let it be ABC, and one line is drawn inside the triangle which is intersecting two sides in P and E, some P and E, whatever. And we said that if this line is if this line is dividing these two sides proportionately, then this PE will be parallel to BC. That is what, if this PE is dividing these two sides proportionately, that means what, in equal ratios, then we said that DE PE will be parallel to BC. Understood or not? That means what is actually basic proportionality theorem? Yes, basic proportionality theorem will be a line which is drawn parallel to, we said parallel to first, drawn parallel to one of the side which is intersecting the two sides, that will divide those two sides in equal proportions or proportionately. In converse part, in reverse, we are saying that if one line is dividing the two sides of the triangle proportionately, then that line will be parallel to third side. Understood? This is converse part of the basic proportionality theorem. Once again I am telling you guys, this geometry is a bit confusing for those who have no minimum basics of lines and angles and triangles. Please do focus on this. Once again I am telling you here, what is basic proportionality theorem? If a line drawn parallelly to the one of the side that divides remaining two sides proportionately. What does it converse says in reverse order? What does it converse says? If a line divides two sides of the triangle proportionately, then it will be parallel to third side. That means these two are parallel. That means we said that this is dividing proportionately and this will be parallel. Then what is our final conclusion? If this PE is dividing this is side, means PA by PB, and this side AE by EC, if those two ratios came same, if these two ratios, this ratio and this ratio, we got equal, that means this PE is parallel to BC. So PE means here DE, understand? So here DE is then parallel to BC, no? So we need to show that DE is parallel to BC means we need to say that ratio between AD and BD and AE and EC is equal. Then it is sufficient to say that DE is parallel to BC. Actually it is not given parallel in the beginning. We need to prove it, understand? We need to show that these two are parallel. So let us do that, start doing that. First of all, what the lengths are given, let us write it down. AB is given and AD is given. So AD means what? This length only, no? So I am plotting here. See, I am locating here. What is that? AD equal to 1.4. This is your 1.4 centimeters. And this total length would be how much? This total length would be AB, and that is given as how much? 5.6. Now what is given on this part? AC is given how much? 7.2. AE is given how much? 1.8. What is AE? Is this AE or not? AE is given how much? 1.8, where total AC is given how much? Total AC is given AC 7.2, right? 7.2. And what does the converse of basic proportionality theorem says? Here, converse of basic proportionality theorem says that if the ratio of these two segments and ratio of these two segments are equal, then this DE is parallel to BC. That's what I said you before. Okay. So how? But we have lengths of these segments, but we don't have lengths of these segments. So now we need to find how to find out the lengths of these two segments BD and CE. Simple. We need to subtract this AD from this entire AB. Understood? So, to obtain, so this proof would be, see here, DB can be found out. So DB can be written as the difference between AB and AD. That means AB minus AD. Right? So this DB would be how much? 5.6 minus 1.4. 5.6 minus 1.4. Is it 4.2 or not? Exactly, 4.2 centimeters. Okay, so we find this length as how much? 4.2. Okay. Now you want to find out CE also. So how to find out CE? We need to subtract AE from AC. So do this. So CE can be written as what? CE can be written as AC minus AE, where AC is given how much? 7.2 or not? From this diagram, 7.2 minus AE would be how much? 1.8. Yes, 1.8. Now difference of these two would be how much? 5.4 or not? Yes, 5.4 centimeters. So that means here, this length is given, we obtained as 5.4. Now we need to apply the converse part of basic proportionality theorem. What we need to check for? Whether the ratio of these two and these two is same or not. So just let us check it. Okay, AD by DB. Okay, AD by DB. So this is AD by DB. How much is this? 1.4 and 4.2. So 1.4 by 4.2. If you multiply and divide with 10 with this fraction, okay, if you multiply this fraction with the 10 and divide also with 10, then the decimals will be gone. You will get 14 by 42. How much would be this? 14 will cut 3 times, so 1 by 3. Okay, now find out the ratio between AE and EC. Ratio of AE and EC would be, AE and EC would be how much? Here AE is 1.8 and EC would be 5.4. Let us write down 1.8 and 5.4. Again, if you here also, if you do the multiplication and division with the 10, this decimals can be removed. Okay, then how can we write? 18 by 54. Now how many times 18 will cut the 54? 18 3 times only, no? So this is also 1 by 3. What did we obtain here? Combinedly from these two conditions, here AB by DB is 1 by 3 and AE by EC is also 1 by 3. That means values of these two fractions are same. From this, what can we say? We can say that, okay, combinedly say that AD by DB equal to AD by DB equal to AE by EC. AE by EC. Okay, so we got the ratio of AD and DB, AE and EC same. So what does the converse of basic proportionality theorem says? Yes, when a line divides, okay, when a line divides two sides of a triangle proportionately, that means what? In equal proportion. See, this and this are equal in proportion or equal in ratios. Then obviously that line will be parallel to third side. What is third side here? BC. Therefore, DE is parallel to BC. So, we could obtain our required result, that is DE is parallel to BC, which we need to obtain. Right? This is what the application of converse of the basic proportionality theorem. Understood? This is the application for converse of the basic proportionality theorem. I hope you guys would have understood this also. Right? So anyways, let us move on to next problem.
Please subscribe and don't forget to click the bell icon for the more updates.